So one of my predictions in relation to quantum gravity is that there's a very big problem with dark energy. I don't necessarily believe that dark energy exists, and I'm not necessarily convinced that dark energy doesn't amount to simply the radiation pressure created by all the radiation emitted by all the galaxies in the universe since roughly the beginning of time. We know that there was a radiation pressure dominated epoch 380 million years or so after the Big Bang, or rather that's when this radiation pressure dominated epoch ended. And then ordinary matter started to take over, and dark energy started to take over, supposedly, whatever dark energy is. And we're now in the situation whereby we have an accelerating cosmos, or a cosmos whose expansion is accelerating due supposedly to dark energy and not radiation pressure. And this is thought to come down to the creation and annihilation of particle-antiparticle pairs in the background. It's thought that space spontaneously generates photons and antiphotons, and these photons and antiphotons mostly annihilate one another. However, very occasionally a photon is released from these sorts of background phenomena, and from these fluctuations in the background, if you like, and that these released photons drive the accelerating expansion of the universe. I take issue with this for a number of reasons. For one reason, I think it contradicts the conservation of energy. It contradicts this idea that energy can neither be created nor destroyed. I'm very, very hesitant to accept creation and annihilation operators in the equations used to govern the universe's mechanics. And for the reason that I don't believe in the creation and annihilation of matter. Sorry, I don't. What I do believe in is that gravitational fields are electron densities, and that tunneling electrons transport photons around the universe, and that this phenomena whereby photons seem to pop up spontaneously in space, I believe that can be explained by electrons swallowing a photon in one location, it tunneling to another location, and then releasing the photon again. And this shows up in all sorts of physics experiments, such as in the Casimir effect, whereby you have two plates which are very slightly separated, and the radiation pressure from photons released in the background causes the plates to very slightly move together. And phenomena such as this. But back to dark energy, I think that this focuses on a major misunderstanding when it comes to radiation pressure, and a major misunderstanding when it comes to general relativity and the Friedmann equations. And the Friedmann equations are, of course, based on general relativity, so I think that there's a flaw with them for that reason. And I think the flaw comes down to the stress energy tensor, which is one of the elements in Einstein's field equations. And the stress energy tensor predicts that ordinary photons would attract one another under their own gravity, and thereby lead to a contracting universe. Is that correct? I think. If it were ordinary radiation supposedly causing the expansion of space, it wouldn't cause the expansion of space, because each photon is mutually attracted to one another under its own gravity, and causes the space between photons to diminish very slightly. And I'm not certain that's something that there's any experimental test for whatsoever. So that leads me to be quite suspicious of it, I think. And I think we could very easily, or not very easily, but through really rather sophisticated experiments, probably try and test this hypothesis that photons mutually attract one another under gravity. I don't know what we could do exactly. Perhaps we could have laser beams running parallel to one another, and if the laser beams are of high enough energy, perhaps there would be some mutual attraction there due to gravity that we could measure in the laser beams. I don't know exactly, but I don't believe that that I don't really believe in dark energy. I don't believe it's some new substance that we haven't yet accounted for. I don't believe in all these additional bolt-ons to physics. I'm a big fan of Occam's razor, and I don't think we should multiply entities beyond necessity to explain phenomena in the universe. What I think we should really be doing is looking at things such as radiation pressure, such as all the radiation emitted by all the galaxy clusters into these regions of intergalactic space between galaxy clusters that are expanding, and try to think about the expansion being mediated by something like that, since we're very well aware of the effects of radiation pressure over all sorts of systems in the universe. In nebulae, for example, we find these huge clouds of gas and dust moving away from the newly born stars in nebulae, and in the solar system even we find that radiation pressure from the sun has an influence over satellites. We can actually harness radiation pressure now in certain experiments, such as the JAXA, the Japanese Space Agency's experiment Icarus, Icarus with a K, by the way, using a solar sail to provide a small amount of thrust to a spacecraft using radiation pressure from the sun. So I think it makes a lot of intuitive sense. And I think it makes a lot of intuitive sense for a good reason, that that galaxies ought to be moving away from one another due to radiation pressure. And we can trap and cool atoms using radiation pressure from lasers. We have a very sound experimental basis, I think, for believing that radiation pressure on large scales would be causing the sorts of expansion that we see in the universe, this accelerating expansion. And I believe, in addition to the ordinary radiation pouring out of galaxies, we have to take into consideration electrons tunneling around the universe, transporting photons here, there, and everywhere, sometimes transporting photons to regions of intergalactic space, whereby they'll be exerting yet again radiation pressure over the galaxy clusters, since I predict that galaxy clusters would be surrounded by this huge cloud of tunneling electrons, which would be repelling incoming photons, and each photon would be generating a very slight degree of kinetic force over the galaxy clusters themselves, and thereby moving the galaxy clusters away from one another. And this, I think, leads to a more optimistic picture of cosmological evolution, since if if these processes due to supposed particle-antiparticle pairs were to be left to run out, it's predicted that it would lead to a big rip, and that we wouldn't be able to observe any other galaxies in the universe ultimately, or we'd only be able to observe the galaxies within our local group eventually, and the universe would become very, very dark indeed, and it would lead ultimately to the heat death of the universe. Whereas what I believe is more like that when the last stars finally burn out and disappear, this effect of expansion of the universe due to radiation pressure would ultimately slow down, and then under gravity you would have the ultimate collapse of the universe back into something more like a Big Bang, and it would conform very much with Roger Penrose's conformal cyclic cosmology. And yeah, that's how the universe would ultimately behave over long periods of time in cosmological evolution. It would go through cycles of Big Bang, then expansion, then ultimate collapse into a big crunch, then another Big Bang, and so on and so forth. And I think that's a much more organic way of looking at the nature of cosmological evolution. I think that heat death is a pretty unlikely scenario, and conformal cyclic cosmology ultimately answers the question of where the Big Bang came from. If the Big Bang came from another period of collapse of the universe, then I think I'd be much more ready to accept the origins of the Big Bang, and accept that as an answer for what came before the Big Bang. And it just seems to make really quite a lot of sense to me, I think, that kind of supposition. But this stuff to do with the stress energy tensor and photons mutually interacting with one another under gravity, I don't believe in that at all. I think the Friedmann equations have been negatively influenced, should we say, by the stress energy tensor. And I think that they paint a misleading picture when it comes to dark energy. And I don't believe in all these add-ons to physics that we seem to have at the moment, such as dark matter and dark energy and all these new particles. I, for that matter, don't believe in antimatter either. And I think that the creation and annihilation of particle-antiparticle pairs is deeply unphysical. And I think that, yeah, we can readily remove antimatter from our equations. And after all, if we can't create matter in a laboratory setting, why would we be able to create antimatter? And I think that what we've discovered with antimatter so far is probably just the tunneling of W plus particles in the background, and really the positron is the W plus particle. And Paul Dirac was laboring under a kind of illusion when he came up with the positron, since he was laboring in total ignorance of W plus particles, which have later been proven to exist. And yeah, I think that the other revelations with antimatter can also be explained by similar phenomenon. I think anti-hydrogen, for example, is just a W plus and a W minus orbiting one another very briefly before collapsing in on one another, and then it's being absorbed by the background in exchange for a release of photons. And yeah, that's roughly speaking how I would explain that. And yeah, I think that dark matter is just a consequence of radiation pressure ultimately, and galaxies moving apart due to huge amounts of trapped radiation accumulating within recesses of intergalactic space between galaxy clusters. And I think I've rambled on about long enough for this video, so I will see you all soon. Thank you very much for watching as usual. Bye bye bye, I love you lots, and please don't forget to like the video.